Hey.
Hi,
Hey,
Nirmal. Welcome to the show, Nirmal. Thanks for coming on. How are you?
well, thanks for having me. How are you doing, Todd and Gigi?
We're good. We're happy to have you. Do you want to give us a 1-second briefing on who you are, where you're sitting today, and
Yeah,
what we're going to talk about?
my name is Nirmal. I work as a product marketing manager for NVIDIA NeMo, which is our end-to-end platform for creating generative AI. I'm right now in Pittsburgh. Todd, I see PGH on your t-shirt. Are you in Pittsburgh too?
I am in Pittsburgh. How did we not talk about this before?
It's a small world.
Are you from? Do you live in Pittsburgh?
No, I was studying for 2 years and then I moved to Austin. My friends are graduating from CMU, so I came to celebrate with them.
Cool. Awesome.
Very cool.
Yeah, I really love
Are you guys going to go to that hot dog place after that I bring up every time anyone talks about Pittsburgh?
I still don't know what I don't know what hot dog place you're talking about. I still didn't we I think we did figure this out last time.
Yeah, we
did. Okay.
Yeah. It's the place that they put the French fries.
Yes. Permane Brothers. Nirmal, have you been to Permane Brothers yet?
Yeah, I've tried it once. Really good.
Nice. Okay.
That's my one Pittsburgh experience. I was there for literally 12 hours and I made sure to hit the hot dog place.
Hey, well, if anybody from our audience is from Pittsburgh, let us know what do you think about Permane Brothers, not an official sponsor. NVIDIA is our sponsor, and we're talking about NeMo. So let's bring it back to NeMo. Nirmal, what is NeMo? What is how does it relate to generative AI? Give us a good rundown of what we're here to talk about.
Yeah, so NVIDIA NeMo is our end-to-end platform for creating custom generative AI, like anywhere, whether it's on-premise or cloud or hybrid, whatever you want to do, NVIDIA NeMo can help you build custom Gen AI applications. Actually brought up a presentation. Let me share it with you so that I can go into details of what NeMo is and what you can.
Yeah. Help me understand what you mean by end-to-end, like end-to-end generative. What does that mean?
Yeah, sure. Before I go there, let me explain a bit about generative AI and how it's being transforming businesses around the world. We are all aware of ChatGPT and how it has taken by storm and it's impacting everyone's life in different ways. So Gen AI, it's AI which generates something. It can be text, it can be design, it can be images, it can be videos. So generative AI is the AI that generates something. It has several applications. For example, text generation, it can summarize your emails, it can summarize call scripts, it can write marketing copies for you. Translation, this is my favorite. Let me give you one example how Gen AI is influencing so many people's life. My dad doesn't speak English, and I introduced him like the LLMs, and he was like, "Oh, I don't know English, I can't use this." And then I told him, "Oh, you can use it in your native language, which is Telugu." And he was so amazed by what LLMs can do, and he was like hooked on it for like hours, and he keeps using and he keeps sending me like this things that he's doing with Gen AI. So it's impacting a lot of people and empowering them to use technology in the way we all want it to. Coding is my personal favorite. I was a developer. I wish I had these LLMs and Gen AI back then when I was a developer. It will make things so easy for me to figure out the bugs and like help me in creating functions and like services, etc. Visual content is also one of the biggest applications we are seeing. People are creating images, videos, like a lot of different type of visual content and art with the help of generative AI. So I want to take one thing from this slide. It is that like companies who invest in Gen AI are 2.6 more likely to increase the revenue by 10% or more. From the audience who are viewing this live, I want to hear how you are using Gen AI in your day-to-day life. So put it in the comments.
Put it in the chat. We want to know.
Yeah.
That'll help us in the demo.
Yes.
Interesting pieces to it.
Yeah, so, we got a sleepy chat room. We got to wake some folks up here.
Get a lot of viewers for a sleepy chat room.
We do. What's up? Where's everybody coming from? Let's hear what are you using Gen AI for as we get into more about NeMo. Go ahead.
Right. You're asking like, hey, what does end-to-end mean? So in general, in any AI model development, there are different steps. So the first step is like where you create the data, you prepare the data, that's the data preparation step, and then you train and customize it to your specific needs. And then you have the deployment stage where you go and deploy and do inference. So these three are common for any AI model in general, but I've taken the LLM model development in general, and taken down these different steps so that everyone can understand it easily. So the first step is like data acquisition, right? Like all these LLMs and the Gen AI models are trained on vast amount of data, whether it's public data available on internet or proprietary data within your company, like PDF files or emails from Outlook or Word documents, any kind of files you can think of. You can use the data to train any generative LLM model. So once you have this data, you have to curate this. Like a lot of this data, there may be duplicates. There may be some information which you don't want it to be trained, like personal information, like names and email addresses and so on and so forth. So you curate the data and you clean it up, and then you do something called pre-training. So the easiest way to understand pre-training, think of it as somewhere like a child who is like 3 years, 4 years of old. Everyone around them speaks, and they take that as data and then try to imitate them, because they can't form sentences, they can't form a lot of words, and there is a lot of things that other people speak which are not good for any child, so that you don't want them to speak. So the parents are like, oh, don't speak like that, but speak it this way. So that's the model customization part. Once you have the pre-training, it's like a child, it's like 4-year child which understands the data but doesn't really form sentences. So you customize it. So customization can be of different sorts. You may want to customize it for question answering. You may want it to customize for summarization. You may want to customize it for your specific use case. So there are different ways to customize the model. And once you customize the model, there is something called information retrieval. So if you think about any LLM, it won't have access to data which is current. For example, if you train LLM on financial specific information, it won't have access to data about how much revenue NVIDIA is doing this quarter, because that's not public yet. That's not in the training data. So how do you add that? You take the data and add it to the LLM. So that's the information retrieval part. By doing this, what you're essentially doing is you're making the LLM answer accurately and up to date, so that it can give the relevant information to the end user. The last is like the guardrails. This is my favorite step. For example, you go to any website, you ask the customer service chatbot, hey, what do you think? What do you use the revenue for your specific company? The customer service chatbot shouldn't have access to that data, right? It shouldn't speak anything about internal data. It should only speak about the customer service, and that's what it is designed for. So you should have proper guardrails for these LLMs and Gen AI models, so that it only does what it's supposed to do and not deviate from what it's originally trained for. So NVIDIA NeMo is the end-to-end platform, starting from data acquisition to guardrails. It gives you accelerated performance on NVIDIA GPUs, and you can deploy these Gen AI applications anywhere you want, from on-premises to cloud, providing the best architecture for you to design some Gen AI applications. And last but not the least, okay, you have built this application. Where do you run it? How do you run it? So that's the inference. NVIDIA has NVIDIA NIM. It's everything is like pre-optimized in a box. Just take it, go and deploy wherever you want. So that's NVIDIA NIM.
Awesome. Well,
Okay.
this really helps break it down. I'm excited to see the demo of it.
Yeah, before we go into demo, I just have like this latest and new thing I'm really excited about, which is the NVIDIA NeMo microservices. So each of these different steps that I have previously explained, we have microservices for different stages of them. For example, for data curation, we have curator, we have customizer for customization, so on and so forth. These are in early access. I really hope you go and try it out. Now, the most interesting part, let's go into the demo. I'm going to pass it on to Enhan and Ankur. They're going to do a live demo for NVIDIA NeMo.
Thank you.
Yeah, thanks for coming on and volunteering that up. I appreciate the rundown.
This is so great. We get a bunch of them.
Oh yeah,
A bunch of NVIDIA coming to hang out. Hey guys.
Here we go. Welcome to the stream, Ankur and Winhan. How are you guys doing?
Good. How are you?
Good.
Thank you for having me.
Yeah, we're streaming right along on a Friday. and one time, Ankur, why don't you introduce yourself before we jump into this demo, and then we'll start seeing NeMo in action.
Okay, I guess I'll go first. Hey everyone, I'm Wonhan. I'm a solution architect at NVIDIA. I joined the company about 2 years ago. I mainly work with AWS customers, mostly on the inference side. But today I'll be doing the demo for NeMo on EKS. SVO.
Hi, everyone. This is Ankur Srivastava. I'm a senior SA here in the Gen AI team. I joined AWS August of 2021, so about close to 3 years now. I am based in the Bay Area here in the East Bay. I help customers with distributed training and inference at scale with services like Amazon EKS, Parallel Cluster, SageMaker Hyperpod, and so.
Okay, Ankur, I'm glad you said that. So today we're going to be talking about EKS and running NeMo in a distributed manner on EKS. Can you give us just a really high level, what is EKS for maybe some of our audience who might not have used it before?
Sure. So Amazon EKS provides you a fully managed Kubernetes platform. So essentially, it really gives you a great way to play around and orchestrate your containerized jobs. You can run really your training jobs at really large scale with hundreds or thousands of nodes, thousands of GPUs. And it makes it seamless and easy for you to deploy your jobs in all your containerized jobs, in this case, distributed training in a really easy way.
Got it. And Winhan, I know you've got a demo queued up, and we've got we've got some time to run through that. Yeah, let's run through it quickly before we before our producer starts hitting us all with sticks.
Yeah, sure. Okay. Wait. Disable this screen. Okay. Perfect. All right. So hi everyone. So we're going to run NeMo on EKS today. So the purpose of utilizing EKS, which is the AWS Kubernetes service on AWS, and is that we can utilize multi-node. So in terms of the training, one GPU is not typically enough. So we go to a lot of nodes, for the sake of the large size of the LLMs today. I'll be showing you guys how to do that on EKS as a demo. So we have two things that we want to create. First one is the EKS cluster. That one has the compute nodes, which has GPUs in it. The second thing we want to create is the EFS file system. That is a shared storage between the compute nodes and also the head node. I'll be doing that one by one. So to create an EKS cluster, we need something called a cluster config, which I've already done that here. We should guess here. And this config, it's pretty straightforward. You specify, the name of your cluster, your region, your AMI, the AMI that you want to use. We'll be using Ubuntu 22.04. That one does not have the GPUs on it, but we'll be using the NVIDIA GPU operator to automatically install that for you. And here you specify the instance type, that has like 4 810G GPUs on it. Here we specify how many GPUs we want, how many instances we want. So each one has 4 GPUs. So in total, we have 8 across 2 nodes. Volume size, how much storage you have, that's pretty much it. And once you have that...
Just to add one thing here. This is a pretty standard config to create a EKS cluster. Now, if you're thinking of distributed training, you want to use larger GPUs like the A100 GPUs or the H100 GPUs. Then I'll share a link in the chat here, which shows example scripts to bring up that cluster. And there are our recommendation is always to use EKS optimized AMIs to spin up managed node groups. So you don't even have to specify an AMI like Winhan is showing here. So you can just specify number of GPUs that you need. And if you have that capacity, then you can just kick off your cluster enough, just few clicks.
Awesome.
Yeah.
The color.
All right, thanks, Ankur. Yeah, so once you have the config ready, created, and you can just use the EKS CTL. This is just CLI that you can install anywhere, either on your laptop or you can start a CPU instance on AWS to do that. So you have this EKS CTL command line. You can just do something like create cluster and -f and just pass in your config file. That's pretty much it. And once you hit enter, this will take about like 30 minutes to an hour, depends on the environments, but mostly at least like 30 minutes for me to set up the cluster. once that's done, you can also go to the console here. So I've already done that before. So if you go to your EKS, okay.
Yep.
This is weird. Okay. Let me do this. So if you
Yeah, no problem. Wenhan, you're not the first person to have a session timeout live on the AWS OnAir stream, so you are good. But while you're signing back in, just to be clear, so with Kubernetes, we have a configuration that is shared across the nodes, right? And that's just telling you how many nodes we should spin up in the cluster, what types of nodes those should be, and then you've just launched out that. You said that takes some time, and now we're going to go to the AWS console. Look at those nodes, look at what was spun up within our cluster, and that's through the managed service EKS.
Yeah.
And one additional point there. So exactly right. One additional point that when you are working with these larger GPUs, A100, H100s, you really want EFA or Elastic Fabric Adapter enabled in your cluster. And to do that, there is just a flag in the config that Wenhan showed, where you just show EFA enabled is true, and you can look online for which instances are supported by EFA, but that's all you need to do. And the link that I will share that has like additional recipes for the latest P5 instances of what you need to do to launch these.
So we have like 2 minutes left, Wenhan. So let's pull up if you want to, the AWS console, and you can re-log in if you want. But I want to make sure that you get through whatever you wanted to show.
Okay.
We're getting somewhere very cool.
You can do that login. That might take you a little bit more time. So I can do that on the terminal here. So you can also check by doing this. So I'm doing kubectl get nodes. So that's the nodes we just created, the 2 nodes that we specified in our config file. I can see that they're ready. And that's the EKS cluster. But for the EFS file system, that's a better step. But we already have step-by-step guide over here that can go through how do you create a file system for your cluster. You only need to be careful with the last step here. Just make sure your EFS file system has a subnet that's mounted to your compute node so that your nodes can know, okay, this file system exists. That's pretty much it. Yeah, and once you have that ready, you can just go to your NeMo, which is also here. That's a repo we're going to be using today. And that will be here. So if you look at the path I have here, this is where I clone the repo, and this is where the directory shows up. So in order to run a pretty quick, simple pre-training job that the mod just mentioned, we can just do something like Python 3, main.py. That's pretty much it. But there are a few configs that you can change. I can quickly go over it. So the most important ones is this one. So here, I know it's a lot, but don't worry about it. Only thing you need to be careful is
There's a lot, but this is helpful.
yeah. And here you specify, what you want to do with NeMo. Here, I'm coming out this training. So I'm telling NeMo, okay, I only want to do training right now. You can do other stuff in it, but you only do training today. Yeah. And once you have that ready, and once you run that script, you will be able to see that your pods are running. So you spin up 2 pods, NLP training worker 0, NLP training worker 1. You can see that both of them are running for a few minutes already. And we also save, the model training to model training. So you can see them right here. You'll create a results directory that's all be done for you. And inside there are another results folder. And in there are a bunch of, logs and event files for your training that you want to look at after it's done. So I think that's pretty much it. Go over the entire demo. It's pretty quick for the sake of time, but I think that goes over everything.
Yeah, and I get it. It's that is a lot of information. I'm sure we could talk all day on any like finer point of this, but I just kind of want to recap it because I always have to say things back out loud just for me to understand it. So I'm going to really quickly kind of summarize this demo and you can tell me from. So EKS, we want to have distributed training because we need lots of computational power to train the models that we may be running inference on for our application. So to do that, we use high-intensive GPU or GPU-intensive instance types within EKS. EKS manages those each one of those nodes. Within the node, we're running the NeMo application through a shared file system, that EFS file system. That's where we might host our training data, our outputs are going to go to that EFS. We've also enabled Elastic Fabric Adapter, which speeds up some of that latency of data sharing across the network for these high-intensive, compute-intensive applications. But once we've installed NeMo, it's a configuration file. We point it at the data. We uncomment the training aspect of it. We hit go, and boom. And just like that, we're at a distributed training situation for our models using NeMo. How'd I do? Did I get it right?
That was pretty good.
Yep.
Yeah, that was really good, Todd. Wow.
Yep.
Thanks. I've been distilling highly technical things for 16 years. I feel like I'm getting better at it.
This sounds like a lot for a person who is new to distributed training, but if you follow the links that we share, this gives you step-by-step way of doing everything very seamlessly.
Ankur, I think that's a great way to end it. Where can people go to learn more? How can they try? Where can they try NeMo? Where would you send folks who might be who didn't catch all of that?
Yeah, so we have a couple of links to share that we'll be sharing in the chat very soon.
Awesome. Hey, that's great. Thanks for coming on, Wenhan, Ankur. Appreciate the demo. I know that was fast, but yeah, it's cool stuff.
Thank you.
Yeah, thank you guys for having us.